today we are going to start image data representation. Now, what is image data representation? Image data representation is the method used to encode, store, process, and display visual information in a digital format that computer can interpret. It includes capturing the characteristic of image such as color, intensity, shape, and structure and translating them into numerical data structure. Image data representation in computer graphics generally fall into two main categories. First, vector representation. Second, raster bitmap representation. Now, raster image representation. Raster image, also known as bitmap image, represent the image as two grid of tiny square called pixels. Picture element. What are the structure of raster representation? Structure. A fixed grid matrix where each pixel store a specific color or intensity value. The number of pixels determine the image resolution. This is the example of bitmap representation. Color depth, the amount of information bits stored per pixel determine the number of color values. 1 bit, 8 bit, 24 bit, 32 bit. 1 bit binary. 1 bit per pixel. 8 bit grayscale. 8 bit per pixel, 256 shades of gray. 24 bit true color. 24 bit per pixel, typically 8 bit each for red, green, blue, RGB color model. 32 bit, often 24 bits for RGB and 8 bit for the alpha channel, which control transparency. This is the example of bitmap representation. Now talking about the character of raster bitmap representation. Resolution dependent. When scaled up, raster image can suffer from pixelation loss of detail because the fixed number of pixels is spread over a large area. This is the example of bitmap representation or raster representation. File format. Common format including JPEG, PNG, GIF, and BMP. Now talking to the vector representation. Vector image use mathematically description, geometric geometric pre, geometric primitives like point, line, curve, and shape to represent the image. To the structure of vector representation. The image is defined by mathematical formula rather than a grid of pixel values. For example, a circle is stored as the coordinate of its center, its radius, and its line fill color. Now talking to the characteristic of vector representation. Independent because the image is defined by formula. It can be scaled indefinitely without losing qualities or becoming pixelate. The computer simply recalculate the formula for the new size. Typical example of vector representation. Now talking to the second characteristic of vector representation, file format. Common format including SVG. Now full form of SVG, Scalable Vector Graphics, EI and EPS. Ideal for logo, font and graphic that required sharp line and scalability. This is the difference of bitmap and vector representation. This is the another difference of raster representation and vector representation. Here you can clearly see in raster representation pixels are visible and in vector representation pixels are not visible. Now the difference between raster and vector representation. Representation of raster and vector representation. Features of raster representation and vector representation. Grid of pixels element. Mathematical formula point line curve. Loss of qualities. Scales infinitely without loss of the quality. Generally large for high resolution photos, often small and depend complexity. Photographs and image with sub or logos, JPEG, PNG, GVG, AI, EPS. Thank you.